Okay, so in this video we're going to solve some of the review questions that was posted online. Okay, so this is for work and energy, and the first question I'd like to do is you should all be able to do questions 1 and 2, where you have to find the force, the work done given the angle and force and all that. Okay, question 3 is 1, where 100 Newton force pulls a 5 kg mass initially at rest. So you have a block that is lying and you pull it with a force of 100 newtons. It's a 5 kg block. It's at rest in the beginning, and the question is, first find the work done on the object. Okay, so the work done by the object in moving at 10 meters is simply given by the equation FD cosine theta, and this happens to be equal to 100 times the distance 10 times cosine of the angle 0. Okay, because the force and the displacement are in the same direction. The 10 meters is pointing to the right, the force is to the right, and so you have 1000 newtons. Great. Now part B, determine the speed of the mass after it moves 10 meters. Now to find the speed, we're going to use the work kinetic energy theorem, and what we have is we have 1000 joules. I made a mistake. Then it should be 1000 joules. So I put 1000 joules in here, and this is equal to KEF, which is equal to 1/2 times 5 times VF square minus 0, because the initial speed is 0, so the kinetic energy is 0. Now this gives us VF square is equal to 2000 divided by 5, which is 400, and which implies that the final speed is equal to 20 meters per second. Great. So this is problem number 3. Now the next problem, which is number 4, has the following thing. What you've been told is that there's a 100 kg mass that is moving with the speed of 20 meters per second. So there's a block that is moving at 20 meters per second. It's a 100 kg block, and it starts to slide on a rough surface, and the coefficient of friction is 0.5, and we need to figure out at what point, how far does it travel for its speed to reach a speed of value of 10 meters per second. So at some point its speed becomes 10 meters per second, and we're going to figure out the distance it travels on the surface. Alright, so we're going to use the work kinetic energy theorem to answer this question. W equals KEF minus KEI. The work done is only by the work by the force of friction, so that happens to be equal to mu Fn. So this work is mu Fn, which is the force of friction, times d times cosine of 180. Okay, and mu is 0.5. The contact force in the problem is simply the weight. It's 100 times 9.8 times the distance d that we do not know, times cosine 180, and this is equal to 1/2 times the mass times 10 square minus 1/2 times the mass times 20 square. Great. So now we have the equation set up. We just need to solve this very carefully. 100 times 9.8 is 980 times 0.5 is 490. That multiplied by the cosine 180 gives us -1. So you get minus 490d is equal to 50 times 100, which is 5000, minus 50 times 400, which is 20,000. So the left hand side becomes -15,000. So D is equal to 15,000 divided by 490, and this happens to be equal to this. It's about 306 meters. 30.6 meters. Okay, so that's that. So problem 9 and 10 are identical problems, so I'm just going to do 9, and then you guys can go ahead and finish 10. And number 9, what it says, determine the amount of work done in stopping a 3000 kg vehicle moving with a speed of 20 meters per second. So once again here we're going to utilize W equals KEF minus KEI. Since the forces are not given, I can't use FD cosine theta, but I've been given the initial and the final speed along with the mass of the object, and the final speed is 0 and the initial is 20. So I have 1/2 times 3000 times 0 square minus 1/2 times 3000 times 20 square, and when you calculate this value you end up getting the work. So it will be a negative work, which implies basically that you have to, the force has to happen to be exerted in the direction opposite the displacement. Okay, in 10 you will basically repeat the same process. Okay, in 11 basically what's happening is a block is going up an incline, and is going up by an amount of it's going from 2.5 to 7.5 meters. Its mass is 10 kg, and it's asking for the amount of work done. Okay, so the work done is nothing but mg h in this case, because it's the force. It's the all we have to worry about is the object going up vertically upward. For any of the sideways motion, the horizontal part of the motion, no work is being done. So all you do is mgh, which is 10 times 9.8 times times the height h, and which happens to be 5. But because the object is going up, gravity is pointing down, object is going up, so we have a negative sign here. So it ends up being equal to negative 490 joules. Okay, so for the object going up, the work will be negative mgh by gravity, and for the object going down, it will be plus mgh due to gravity. Okay, so it will be negative because it's going up, positive if it were going down. Okay, problem number 19 is where it says that the spring is stretched. They're given a spring constant 50 newtons per meter, and you stretch it by we're stretching it by 0.12 meters, and it's asking you to find the force. Okay, so the force, the magnitude of the force is simply kx. We just ignore the negative sign because it just gives us direction, so we don't care about that. So it is 50 times 0.12 will be the magnitude of the force, will be 6 newtons. And then the question is how much energy is stored in the spring. The energy is stored, potential energy stored in the spring is 1/2 k times x squared. So it is 1/2 times 50 times x, which is 0.12 square, and you can get a value for this, and it'll be, once you get the number, that's your energy stored. Okay. So for problem number 20, what you've been told is a block of mass 0.8 meter. Oh, it should have been 0.8 kg, and I made a mistake there. So 0.8 kg block is pushed against a spring constant 150 newtons per meter, and the spring is compressed by an amount 0.12, and the block is released. Determine the speed. So we're going to use MEI equals MEF to solve this problem. In the beginning, the only energy is that due to the spring compression. So that is equal to 1/2 kx squared. So it is 1/2 times 150 times x squared, which is 0.12 square. And in the end, all you have is the kinetic energy of the ball, because the spring has no potential. The block is not going. The height of the ball is not changing. So it has no potential energy. So all the energy is simply in the kinetic energy of the block. So it happens to be equal to 0.08 times v squared. And from this, the halves cancel out, and you can solve for v. Just go ahead, just get a number for v, and then it's all good. Okay. So that's the first part of the problem. In the second part, what it says is now the same ball is, instead of being shot horizontally, is going to be shot vertically. So you have the ball and it's going to be shot vertically, and the question is how high does it go. Okay, so once again we're going to use MEI equals MEF, and what we'll do is the initial energy is all due to the spring, so it will be 1/2 times 150 times 0.12 square, and in the end all it has, because once it reaches as it goes up at some height, okay, all it has is potential energy due to gravity. So that is equal to mgh. So it is 0.08 times 9.8 times h, and you can solve this equation for h and obtain the maximum height. Okay, so the problem 20 is a repetition of 21 is a repetition of this one. So let's do 22. And in 22, what's happening is a block of mass 150 kg is moving with a speed of 12 meters per second to the top of a 20-meter high hill. and we have to find the speed at points A and B, and we have to also find the height h. So to find the speed at A, what we're going to do is use MEI equals MEF at the location A. Now MEI is equal to 1/2 times 150 times 12 square plus 150 times 9.8 times 20, and this is equal to, at the bottom of the hill it has no height, so all it has is the kinetic energy. Okay, so plus 0 for the potential. You can solve this expression for V and obtain the value. For part B, I'm going to use MEI equals MEF at the location B, and once again we'll have the same number on the left hand side, and all this will be equal to 1/2 150 times VB square plus 150 times 9.8 times 10. Okay, and then you can solve this for VB. Just be careful to the algebra correctly and solve it for VB, and you should get the answer. And then the last part is C, where we have to find, once again, we're going to use the same MEI as the previous problem, and all this is going to be equal to 1/2 times 150 times 25 square, because it says at what height is the speed going to be 25, and plus 150 times 9.8 times the height h, and you can solve this. You get a number for MEI from the previous one, and you can solve this and obtain the value for the height. Okay, so I hope that helps, and you're ready for the test tomorrow or Wednesday, depending on which class you are. Bye.